What does the commutative property mean? If you remember, the commutative property of addition says this. If I take a number and I add another number, that's the same as taking that second number and adding that first number. If I were to look at an example, 5 plus 2 is going to equal 2 plus 5. To do that, I'm going to do the math on the left side. 5 plus 2 is 7, and 2 plus 5 is also 7. So the commutative property of addition works. What does it mean for multiplication? Well, in multiplication, if I take a number a and I multiply it by a number b, that's going to be the same as taking b and multiplying it by a. If I was going to show that this worked, I would just plug in a couple numbers for a and b. 4 times 2 is 8, and 2 times 4 is also 8. So the commutative property of multiplication and addition works for integers. Is the commutative property always true? If I look at subtraction, a minus b would be the same as b minus a. Well, let's find out. Let's take those same numbers. 5 minus 2 equals 2 minus 5. On the left side of my equal sign, 5 minus 2 is 3, and 2 minus 5 is negative 3. 3 does not equal negative 3, so the commutative property of subtraction is not true. If I look at division, a divided by b is the same as b divided by a. Let's plug in some numbers for a and b. The commutative property says if I switch the order, I should get the same answer. Let's try it. 4 divided by 2 is 2, and 2 divided by 4 is 1/2. 2 does not equal 1/2, so the commutative property of division is not true. It's false. Let's try the commutative property in the matrix world. If I want to show that the commutative property of addition works in the matrix world, I need to take matrix A plus matrix B and show that it's the same as matrix B plus matrix A. So let's try an example using matrix A and matrix B. I'm going to keep my equal sign, I'm going to keep my plus signs, and I'm going to plug in matrix A and matrix B. Now I want to make sure that my equal sign stays lined up, so that's the first thing that I'm going to drop down. And now I'm going to do the math on the left side of my equal sign and write my answer right down below it. I'm going to start with a 2 by 2 matrix and add a 2 by 2 matrix, so my answer is going to be a 2 by 2 matrix. And to add matrices, I just add the corresponding entries. 4 plus 1, negative 2 plus 0, 6 plus negative 2, and negative 1 plus 4. On the right side of my equal sign, I'm going to start with a 2 by 2 and add a 2 by 2, and for an answer, I should get a 2 by 2. And to add matrices, I just add the corresponding entries. 1 plus 4, 0 plus -2, -2 plus 6, 4 plus -1. Again, I'm going to keep my equal sign right in the middle, and I'm going to do the math on the left side of my equal sign. 4 plus 1, -2 plus 0, 6 plus -2, -1 plus 4. And I'm going to do the math on the right side. 1 plus 4, 0 plus -2, -2 plus 6, 4 plus -1. After I've done all the math, now I can check and compare my two matrices. If you look, these two matrices are equal to each other. So the commutative property of addition is true in the matrix world.